Hello, good morning all. So today here we are to discuss one of the beauty problem of graph, which is taken from CSES sheet, and this problem name is distance queries. So this is a very good problem covering three different types of logic and topics. So let's first go through the problem, what the problem is saying. Here we need to process few queries of the form. What is the distance between nodes A and B? So we are given here n nodes. We are given here two integers n and q, where n represents the number of nodes and q represents the number of queries. So in n minus 1 lines, here as you can see that 1 and 2 represent there is an age between 1 and 2. Similarly, 1, 3 represent there is an age between 1 and 3. And we need to find the answers to the q queries. Let's suppose here q is 3, so we need to find the distance between 1 and 3. Similarly, we need to find the distance between the node 2 and 5 and distance between node 1 and 4. So one can think of like a brute force approach covering the depth of any node from the root and finding the difference of those, yes, a plus b minus that. So it can take up to the time complexity of O of 2 into n, which will be not accepted. So we need to think some the optimized approach. So let's go through how we can solve this. So see, let's suppose here is a node named Tanishq and here is the node named U. And we need to find the distance between Tanishq and U. So this is very basic math that let's suppose the distance between the root node and the Tanishq is T and the distance between the U node named U and the root node is Y. And let's suppose this distance, which I'm showing you, is L. So we can write that distance Ty is equals to distance T plus Y minus 2 into L. Why minus 2 into L? Because this distance is been covered two times. So when we will add T and Y, it will be covered two times. So when we will subtract it two times, then we will get this distance Ty. That is the distance between T and Y. So this distance T can be found as the depth of the node T. Similarly, Y can be found as the depth of the node of U, and L can be found distance, the depth of the that L from the root node. So depth we can find by using simple DFS approach if you have studied graph. But how shall we find this L, and what is this L is basically? So here L is basically the LCA, lowest common ancestor, and we will find a good approach to solve to get the value of this LCA. So this point is basically our LCA, lowest common ancestor. And what is this lowest common ancestor? When we will move, let's take this node T and U only. So when we move upward from this node Tanish and upward from node U, then we will, the point which is common is that which which is called as LCA. So when we are moving upward from Tanishq and upward from U, the common point where these meet is defined as LCA, lowest common ancestor. And we need to find the distance of this LCA from the root node. So if the time complexity can be O of n q, let's suppose O of n square also. So we think of two methods, two approach, binary search or divide and conquer. And the other approach is the power of 2, which is not that common. And in this, we will use the power of 2 concept. So let's see how we will do that. Here I have created a table in which this 1, 2, 3, 4, 5 represents the node and the row, this row represents their parent. So this parent is being stored in the power of 2. because we are using the concept of power of 2 here to optimize the solution. So here 1, 2, 3, 4, 5 the nodes are being placed. 2 to the power 0 is saying that 1 का 2 to the power 0th parent कौन है यानी कि first parent कौन है. So we will, you can see from here this example is being taken from the problem only. So 1 का फर्स्ट पेरेंट कौन है. अगर पीछे जाएंगे तो हम लोग जनरली माइनस, वी जनरली स्टोर -1. सो हियर वी विल नॉट स्टोर -1, हियर वी विल स्टोर 1. ओके. सिमिलरली 2 का फर्स्ट पेरेंट कौन है, 2 का 0th पेरेंट कौन है, तो यू कैन सी 2 का 0th पेरेंट 1 है. फिर 3 का फर्स्ट पेरेंट या फिर 2 का 0th पेरेंट कौन है, तो 1 है. सिमिलरली 4 का 3 है, यू कैन सी 5 का 3 है. And if someone asks who is what is the third parent of or the fourth parent of this 4, so you will find that it is going beyond 1, or and you can say -1, but in place of -1 we have to put the root node only. So in this way this table is being created. And how we will write this the formula of this creation of the table. So let's see. Suppose if you have been asked fifth का fourth parent क्या होगा. So when we are creating the table, what we are storing is, first of all we have make the row 2, then we are making the row 4, or the 2 to or 2. So the row which is being created first is this 2 to the power 1 row. So in using that row we can only create the next row. So 4, fourth, fifth का fourth parent कौन सा है, तो फिफ्थ का फोर्थ पेरेंट कौन सा है, तो उस फोर्थ को या फिर जो भी हमें दिया फिफ्थ का एट पेरेंट कौन सा है ऐसा करके दिया, तो वी विल ब्रेक इट इनटू द पावर ऑफ 2. सो 4 को वी कैन रिप्रेजेंट राइट इट लाइक 2 + 2. तो पहले हम लोग कैलकुलेट करेंगे कि सेकेंड पेरेंट क्या है फिफ्थ का. तो सेकेंड पेरेंट फिफ्थ का क्या है, यू कैन सी इट इज 1. और अब इस 1 का हमें फिर से निकालना है कि सेकेंड पेरेंट कौन सा है, क्योंकि यहाँ पे 2 है. इस 1 का सेकेंड पेरेंट क्या है, 1 है. सॉरी, या इट इज 1. 1 का सेकेंड पेरेंट 1 है. इससे हमें फोर्थ जो नेक्स्ट रो बनाना है वो हम पिछले रो से बना पाएंगे. सो दिस इज द जनरल फॉर्मूला टेबल ऑफ आई नोड, यानी कि नोड का ith पेरेंट कौन सा है, तो वो इस जगह पे सिचुएटेड है पिछले टेबल ऑफ i-1 में. और उसी जगह पे हम लोग जा रहे हैं, तो टेबल ऑफ i-1 नोड. You can just write it in the copy and you will get how this formula has been arrived. Basically, we need to calculate the next table line. So we will first find the what is stored being on the previous line. So in this way, we will form the table. Now, the most important part, how we will solve the query that. So let's say just not focus on the question. Just right now, we will focus on the concept. Then we will move to the question. So let's say it is asked find the kth parent of 5. So, and let's say the value of k is 3. So we have been asked to find the third parent of 5. So what we will do is we will break this k into the bit binary form. So 1, 1. Now what this 1, 1 represents. So if we need to find the third parent of 5, so first of all, we have broken down k into two things, 2 to the 0 and 2 to the 1. So first we will find the 2 to the 0th parent of 5. Let's suppose that is sk. Now that sk is will be changed to the what we are getting to the 2 to the 0th parent of 5. And then we will find the what the value we have got, उसका 2 to the 1th parent find करेंगे. So are you getting my point? Let's say कि हमें find करना था थर्ड पेरेंट ऑफ 5. तो थर्ड पेरेंट ऑफ 5 या फिर कोई भी जो पेरेंट मांगा है तो उस नंबर को k मान लेते हैं. उस k को हम लोग बाइनरी रिप्रेजेंट में तोड़ देंगे. अब जैसे कि यहाँ पे 3 था वो k का वैल्यू, तो 3 को हम लोग 1 1 लिख दिए. तो 1 2 to the 0th. तो हम लोग पहले फाइंड करेंगे 2 to the 0th parent of 5. मान लेते हैं 2 to the 0th parent of 5 कोई वैल्यू आता है x. अब वो जो x है उसका हम लोग 2 to the 1th पेरेंट चेक करेंगे वो क्या है, वही जो होगा वो फिफ्थ का थर्ड पेरेंट होगा. सो this was the concept that how we can find the kth parent of any number. Now what is being asked in the question, then here we will go. So right now for finding any parent, for finding the LCA, we need to, for the optimized approach, we will see like this. Suppose here we have Tanish at right now state as node V, and here it is U. Now we need to find the distance between V and U. So first of all, we will calculate LCA. So I have right now taught you the concept of how to get the kth parent. Why? Let's suppose here we have V and U. So to calculate LCA, first of all, this V and U need to be on the same level. So K was being so first in the code you can see first we need to have U and V on the same level. So where it is. Hmm. So here it is depth of U minus depth of V. That is how much depth it needs to be covered so that both the nodes can be on the same level. And when they will be on the same level, then it will, from that same level, we will find the LCA. It will be very easy for us to find the LCA. So when they are on the same level, like here, now from here, we will move up and we will move up in the power of 2, starting from maxi. So we will move in such a way when their parents are not equal, we will not move. But when their parents are not equal, we will move. And when their parents are equal, we will not move. So here, suppose this point move to this and this point move to this. So you will find that this point is common to both. So we will not move. And in this way, suppose if we move to this point and from here we move to this point. So these 2 points are not common. So we will move. You will be better understanding this all approach when I will show you the code. So let's first see the code. Here we have created the solve function by which we are connecting the edges A and B. Now this function is for finding the depth of any node, which is very common. After that, we need to find the LCA, and this is what we need to find for calculating this formula. This is the this will be the answer. This will be the answer, but the basic concept we need to know is the LCA. So let's see the code of LCA, how we will solve that. Hmm. So let's say we have two nodes U and B. If the node U is large, is at more distance than the node V, so we will swap it accordingly. Now, the this is the value K, that how much depth is U from V, so that we can get both the nodes at the same level. After that, this is the lifting method that if that I have taught you that if the value of K is 3, then we will break it into bit 1 1 and we will move it accordingly. So पहले क्या है K को हम लोग बाइनरी में रिप्रेजेंट करेंगे और वहां पे अगर स्टेट बिट होगा, ये स्टेट बिट चेक करने का तरीका है फ्रॉम बिट मैनिपुलेशन. तो अगर वहां पे स्टेट बिट होगा तो हम लोग वो उस पेरेंट को चेक कर लेंगे. जैसे 1 1 था तो 1 एक स्टेट बिट है, तो उसका 2 टू 0 पेरेंट आएगा. फिर दूसरा 1 है तो 2 टू 1 पेरेंट आएगा. तो वहां से हम लोग उसके पेरेंट को यानी केथ पेरेंट पे चले जाएंगे. अब जब वो सेम लेवल पे आ गए तो वहां से हम जंप करेंगे. हियर इट इज, लेट्स टेक मी द नेक्स्ट. तो अब हमें पता चल गया कि कितना जंप मारना है. तो यहाँ से वो हम जंप करेंगे और जंप तभी करेंगे जब दोनों के पेरेंट्स यू और वी के सेम नहीं होंगे. अब ये मैक्सी क्या है? तो मैक्सी वो नंबर ऑफ रोज है. जैसे 2 टू 0 था, 2 टू 1 था, 2 टू 2 था, तो 2 टू द पावर जो है वो आई का वैल्यू वही वो मैक्सी है. और मैक्सी का वैल्यू क्या होगा? तो बेसिकली हम जानते हैं कि डेप्थ ऑफ एनी ट्री, एनी नोड क्या होता है? लॉग लॉग एन होता है टू द पावर 2. तो यहाँ पे n का वैल्यू हमें दिया था 10⁶, और log 10⁶ टू द बेस 2 करेंगे तो अप्रोक्सीमेटली 17 के इक्वल आता है। तो हम उसको सेफ्टी के लिए 20 ले रहे हैं मैक्सी का वैल्यू, और हम नीचे से स्टार्ट कर रहे हैं। यानी कि टेन टू मान लो 17 तो 20 है, तो 20 से या फिर 19 से स्टार्ट कर रहे हैं। और जंप जंप हम लोग किसी भी नोड से तभी मारेंगे जब उनके पेरेंट्स इक्वल नहीं होंगे। And at the end we will return table of u0. This will give the value of LCA, and when we'll get the value of LCA, then we will put that in the formula. Yeah, so we will put that in the depth of n's. So depth of a plus depth of v minus 2 into depth of n's. This n's is basically the distance L, and in this way we will get the answer. So the overall concept included in this question was LCA, binary lifting, and obviously the graph. So that's all. For any query, please comment. Thank you.